So that's a procedure section. So how many sections do we have in a CL program? 4. Right at the top, we have the comments, which is optional, called program information section. Then we have a program linkage section, which is where you have the PGM. That's figure 6.6. And then you have the declaration section, which is 6.7, where you declare all your files and variables. And the rest of the stuff is the meat of the program, which is figure 6.8. That's where you get to see the comments and the return statement, the end of the program, the error handling routines and everything. And as we progress through the code, as we progress through the course, you will get to see more and more of this stuff. Like in figure 6.8, if you look at the listing, you will see that we are using comments, we're using global messages, we're using an if condition. If you turn to page number 86, we are using error handling. A lot of this stuff will unfold as we start working with CL. On page number 86, however, author talks about one more thing, which is the procedure section begins with the first CL command following the declaration, so the PGM. So what happens is towards the end of the program, you type end PGM. As you can see in figure 6.8 on page number 86, the very last line is end PGM. Then author talks about that every CL source member should include one end PGM command as the last line of the member. The procedures section consists of 4 segments. So the very last section, which is called the procedure section, it itself is divided can be divided up to 4 sections. One is the global message monitor, one is the main procedure segment, one is the error procedure segment, and one is the subroutine segment. So global message monitor is basically, it's a global error handling. It just takes care of the most generalized error handling problems. That's your global monitoring stuff. Followed by the main procedure segment. That's the main meat of your program. Followed by error handling. So that's basically any other typical error handling that needs to be done. And finally, subroutine. Subroutine is like functions that you can call, you can pass parameters, but we call them subroutines because they're part of the main program as smaller segments that you can call. But to understand it from Java or from C#'s perspective, you can call it like static methods. But we don't have classes here, so just for your understanding, okay? Okay, page number 87. The error procedure segment appears in all but the simplest CL programs and includes the major error handling procedures used by the program. The beginning of this segment is identified by a label. As you can see on page number 86, right at the top, we have an error colon, which is the label that we're using. The same label specified in a global monitor message command and can be ended in a variety of ways. The most common way to end the error procedure segment is to execute a CL command that sends a special type of message called escape message. So as you can see on the very last line, the send program message, under the comments and final escape message has the message type escape, which immediately ends the CL program. So if you make it to that section and there is an error in your code, it'll just terminate your CL program. The contents of a message indicates the error that caused the program to fail. We need only realize that it is part of the procedure section of the CL program. At the end of the procedure section, the program may include a subroutine segment. A subroutine is a named block of command within a CL program that performs a particular task. The commands in the subroutine can be processed repeatedly and can be invoked from more than one point in a program. So it's like a function that you can code once and you can invoke multiple times. So now look at the complete listing on pages 87 and 88, where all things are put together, mostly all things put together except for a subroutine. And you can identify all four sections. Right at the top, you have the program information section, followed by the linkage section. And you can see in the line of the linkage section, PGM, that's how you can pass parameters in the program. You see parm and you see a list of variables. Those variables are declared in the declaration section. Unlike Java or C#, where parameters have the data type right there and then, in CL, the parameters are declared afterwards. They're just listed at the top. Followed by the declaration section on page number 88, you will find the procedure section, which includes the global message. It includes the meat of the program, which is followed by the error handling. And then you may have a subroutine, or you can simply end the program. This one doesn't have a subroutine. Then you guys can read the chapter summary on page number 89 and go over the key terms. And when you are done with that, give me a green check.
Sorry, what did you want us to do?
I want you to read the chapter summary and the key terms on page 89.
Okay, chapter summary and key terms. Okay, I just didn't hear the second thing. Thanks.
Mm-hmm. So once I get the green check from everybody is when we will start with chapter number 7, which is page number 93. So for those of you who are done reading the chapter summary and the key terms, can turn to page 93. In the meanwhile, I will open the chapter 7 PowerPoint. Okay, so now that I've received check from everybody, so now we'll start with chapter 7, page number 93, which starts out with declaring program variables. And some of this we have already done, so it'll be easier for you to understand this. Page number 93 talks about what is a program variable, which you guys already know. It's the same definition that you have in any other programming language, that it's a named location in the memory where the values are kept. You can call them by name. Behind the scene, there are nothing but memory places. Unlike a constant, the variable stored in a variable can change. For constants, the values will stay the same. On page 93, in the second paragraph, under what is a variable, the author then talks about that you can also use variables within CL commands as substitutes for nearly all command parameters. For example, if the command goes like this, display tape, and then you use a keyword dev, inside the parentheses, you're using tap01. Instead of doing that, if you have that value tap01 stored inside a variable, you can actually use the variable right there and then. In the dev, in the parentheses, you can use ampersand and a variable name. So what does that tell us? That tells us that in CL, all variable names are preceded by an ampersand. Unlike Java and C# that don't use any symbol for variables. How to declare a variable? Well, variables are declared with the DCL command. And followed by, you can either use keyword notations where you can mention the keyword and a variable name, type and a data type, or you can just use positional notation. Either way is perfectly okay. At the bottom of page number 93, author shows you another one called length, because characters are also declared with length so that it knows how many characters it can take. Naming a variable, page number 94, the first parameter on the DCL command, var, is required, which is the name of the variable. The parameters are assigned a name, and every variable name begins with an ampersand, followed by 1 to 10 characters that uniquely identify the variable. Permitted characters following the ampersands are alphabets A through Z, lowercase, uppercase, at, hashtag, or $sign. The remaining characters can be everything plus numbers and underscore. So underscore or numbers cannot be used as the first placeholder. Variable names cannot embed blanks or other special characters such as exclamation mark, ampersand, percentage symbol, or stars, asterisk. Following are the data types. Page number 94, it shows you there's a character data type. There is a logical data type like true, false, which is basically 0, 1. We have a decimal number data type, which is packed decimal. We have integer for signed numbers like negative, positive, and you have uint for unsigned, which is only positive numbers are allowed, no negative. So since you are using an unsigned, so your limit doubles. You can have the negative plus the positive, so you have two sides. That's why the limit doubles for unsigned. And then you have pointers. So what is a pointer? A pointer is a place in the memory which is not to be used as a variable's value. Rather, it is used as a memory location of a variable. So you can use a pointer to point out to any variable. It's a little bit dangerous to work with pointers because you're directly messing up with the memory management system of your program. So you should be careful when you're doing pointers. There are some examples of declaring variables with data types. Moving on to page number 95, which shows you this table, which shows you each one of the data types with its appropriate length, minimum, maximum, and default length in bytes. So if you just mention character and do not mention the length, it just goes 32 bytes. You don't want to do that. So that's why, you can mention however many bytes you want. If you don't, then it defaults to 32 bytes, which means 32 characters. And on page number 95, you can see several examples throughout the page. So after you are done reviewing the table at the top of page 95, I would like you to go over all the examples mentioned on page number 95. Did anybody join us who was not with us in the early part of the class? No? Okay, so everybody who were here before are here now. So everybody over here has completed the quiz that we did in the earlier part of today's class? Or no? Okay, oh, okay, I got one response here, William. So anybody else here who was not here with us earlier today? Oh, we have one more hand up, Christian. Okay, so for both of you, in the first half of today's class, we worked with the quiz, which is under this week's button. It's called Quiz Chapter 4. And then we looked at chapter number 6, and now we are looking at chapter 7. I don't know, when did you join, Christian? Just recently did you join, or were you with us for some time now?
I was with you from page I believe it was 94.
Oh, okay. So that means you joined in chapter 7. You were not here for chapter 6.
I was not.
Okay, okay. Let me update the attendance sheet here. Okay, yeah, you had something?
Yeah. Would you like me to do take the quiz now?
No, you can take care of it after class. I just
Okay.
wanted you to be aware that, you know, that activity is out there. So you were not here when we did that in class. So make sure you take care of it after class.
Okay, thank you.
Mhm. Okay, so once everybody look at different examples of declaring variables on page number 95, you turn over to page 96, and I want you to read that gray section at the top of page 96, which is coding and style. And William, you too, you can take care of it out after class, so you don't have to do it now. Otherwise, you'll be missing on the class lecture. Okay, next we will be looking at specifying an initial value, the very first value for the variable, which is at the bottom of page number 96. And you specify a value through a value keyword, and then you can mention the first initial value in the parentheses when you're first declaring the variable. So This is how you could be initializing your variables with values. Now, if you want to look at how character variables are assigned values, you can look at all these different examples on page number 97. So page number 97 show you a different example, and you can see some of them right here as well. So what I would like you to do is to read page number 97 and its examples and the first half of page 98. Pages 97 and first half of page 98. Okay. Now, once you are done with page number 97, you can then transition to page number 98 and look at the first half, and let's talk about the logical data type, which can be assigned a value of 0 or 1. 0 means false and 1 means true. Similarly, on the same page, page number 98, you can see that we have decimal, which is for numbers with decimal places. Decimal values can include any numbers 0 through 9, and decimal point also allowed. Number of decimal must fit in the length. May include leading pluses or minuses for positive and negative numbers. Here we have some examples. Decimal with no precision, with 2 decimal places. Now, when you say 5 space 2, you don't use comma in between. 2 comes out of 5. So you basically have 3 placeholders for the digits and 2 placeholders for the decimal, total 5. Okay, so total 5, and you can give negative or positive values. Then comes on page number 99, how you can give integers and unsigned integers. Unsigned integers are absolute values, no signs to them. And integers can be negative. As you can see, the different declarations right here on page number 99, page number 99. Integer variables must fall within negative 32,000 to positive 32,000. A 2-byte unassigned integer must be between 0 and 65,535. 4-byte integers have extended ranges. The following example correctly assign initial values to integer variables. So also at the bottom of page number 98, that's an error. So the negative sign has to be in front of the number rather than behind the number. So that'll be invalid. Similarly, if you look 2 lines above at the bottom of page 98, you will see that we are assigning character numbers, or you're assigning characters to decimal data type. That's also invalid. That's not allowed. And these last 2 are also invalid because you're putting too large of values in these variables. So that will also be considered invalid. Okay. Moving on to slide number 12, which is about miscellaneous rules for initial values. When you specify an initial value for a variable, you must not only ensure that you use the correct data type, you must also take into account the length of the initial value. If you specify a value on the length parameter that is too small to hold the assigned value, the command is invalid. If the specified length is larger than that of the value, the CL compiler appends blanks or zeros to the value to match the specified length. For character variables, the initial value will be left adjusted within the variable and padded to the right with blanks. So for example, the value Mary is followed by 26 blanks. Okay. For decimal variables, the value will be placed in the variable according to the decimal alignment specified, and if necessary, padded to the right and left with zeros. For example, the following command initializes the variable my number to a value of, because you said total 7, right? Out of 7, 2 are decimals. So how many are left for the whole number piece? 5. Out of 5, you're only using 2 digits, so the remaining 3 will be padded with 0. So it'll be 00016.1, okay? And then followed by another 0 because you said I want 2 decimal places and you only provided 1. You should note that if you specify the value parameter of the DCL command without specifying the length, CL sets the length of the variable according to the length of its value, ignoring the default length shown earlier in the chapter. For example, the following command assigns a length of 7 bytes to the variable, even though a character variable with an unassigned length is 32. But since you are giving an initial value, the initial value will then dictate the size of the variable. The following command assigns a length of 3 bytes with 2 decimal places to the variable pi, because you never specify the size. Okay, turning to page number 100. You cannot assign an initial value to a variable if the variable name being declared also appears in the parm parameter of the PGM. So if it is coming in through a parameter, then you cannot assign, a value, an initial value, because you only declare it, the value will be coming in through the parameter. So what you see right above using DCL with pointers, those 2 lines are considered an invalid piece of code. Okay, then comes the pointers. As I told you, pointers are simply memory locations which point to the memory of other variables. So slide number 13 talks about pointers which hold storage addresses. Lengths are not allowed. They're simply memory locations of others. So for example, in this case, we're saying that I'm declaring a pointer called my pointer on page number 100 I'm talking about, and the data type is PTR. Examples shown to you in the book is that let's say if we have a variable called my name, character, size 10, value is John Adams. Now you're saying that my pointer is pointing to the memory of address. So you can use the pointer to point to the address of another variable. The address parameter also lets you enter an offset, a number of bytes from the beginning of the reference variable where you want the pointer to point. In the following example, my pointer would point to the 6th character of my name because we said that you are offset by 5. So which is 0, 1, 2, 3, 4, 5. So starts from the 6th. So in this case, my pointer would point to the first A in John Adams because that's the location of the 6th character. That is 5 bytes to the right of the first byte. So that's basically how the pointers are used. Then comes declaring based variables. The concept of base variables is tied to the concept of pointers. Normally, when you declare a variable, the program will automatically allocate storage to hold the variable's value. It is possible, however, to declare a variable without allocating any storage to it. Instead, the variable's value will depend upon the value stored at an address location identified by the pointer. The resulting based variable always depends upon its associated pointer to reveal the variable's value. Because your program can change the value of the pointer while it is running, it can use based variables to manipulate arrays of values or to map variables in the program to other variables. So to declare a based variable, you use stg storage and basing pointer variable parameters of the declared command. So let's say we declare a pointer called my pointer. Then what we do is we declare a based variable, character, size 10. We're saying that storage is based and the pointer is my pointer. This example will declare a character variable based variable that is based on my pointer variable. The value of base variable will be the 10 bytes beginning at the location addressed by my pointer. Before your program can use base variable, my pointer must be initialized to a valid address. Using the address function discussed, will be talked about in chapter number 8. If my pointer does not contain a valid address, when you try to use base variable, an error will occur. So, for example, declaring defined variables on page 101. Defined variables enable a CL program to give a name to a portion of an already declared variable, or to allow 2 different variables to share the same storage. Defined variables make it easier for your program to break down variables that may contain complex data structures. As with based variables, CL does not allocate separate storage for defined variables. Instead, the defined variables rely upon the storage allocation of another variable that is declared to your program. To declare a defined variable, you use the stg and defined variable or define on parameters of the DCL command. So you declare a variable, let's say my object, character size 10. You declare my file as a defined variable, which is the storage is defined versus based, and it is on the object, my object. That's a defining variable. That's what's defined on. So now you can declare another variable, my library, which is also defined, and it could be defined on my object, and then you can set it to be from the 11th location onward. So in this example, the my object is 20 bytes. This variable is actually a data structure of 2 elements. The first 10 bytes belong to the first element. The remaining 10 bytes belong to the second element. So the my file whose size is 10 can only look at the first 10 because that's what its size is. The second mylib, the second one, which is mylib, whose size is also 10, but it starts at the 11th block in the my object, so it can read only the last 11. So that's how you can declare variables that can read portions of another variable. So you can also employ a defined variable to use the same storage, but with different data types. So for example, if you have a my character size 4, you can declare my binary integer size 4, which is defined, and it will be grabbing its value from my char. So your CL program can then use a whichever variable, my char or my bin, in this case, best suits its needs, and it can use it based on however it wants to use it. On page number 102, the next example uses a variable as a data structure with subfields of different data types. So you have a my structure size 52. You're declaring a defined variable my bin on the first 2, and the remaining 50 are being given to the second one, which starts from position 3 onwards. So in this structure, the first 2 bytes can be an int, and the remaining bytes are character. So that's something unique. You don't really have that kind of stuff in Java or C#, where a variable could be split into other variables in terms of storage. So what I would like you to do now is go over the DCL examples on pages 102 and 103. Okay, and give me a green check when everybody is done looking at DCL examples on pages 101, 102 and 103. Then we'll talk about the DCLF command. So whenever you are done reading through these examples on pages 102, 103, give me a green check. Okay, so we still have maybe 2 or 3 people, couple people left. We're still reading. Okay, now let's move on to the DCLF, which is the declare file command. This is the command that can be used to talk to files. So page number 103, the CL program can process display files or database files. You can use a display file to send a screen to a workstation and to receive from a workstation information that you will use in the program. The display file would contain the screen layout, including the fields that you can display or key into. You also can use your CL program to read records from a database file. For database files, only input operations are allowed. You cannot use a CL program to write or update a record in a database file. If your CL program uses either a display file or a database file, you must declare the name of the file to the program using the DCLF. For example, the following command, DCLF file payroll/emmast. So payroll is the library / emmast is the file inside the library, which is EMP master file. So it will have access to these fields. So it makes the database file employee master in library payroll available for processing. When you declare a display or database file in a CL program, the file must exist on your system before you can compile the program. Okay. So that's all on page number 103. In the example above, which is also on this slide, slide number 17, if the file employee master contained fields like employee number, name, and rate, the CL compiler automatically declares the variables for each one of the fields, which will be named exactly the same as the fields. These variables would have the same general attributes like the data types, exactly the same as the fields in the database. A CL program can use up to 5 files. It follows that and as many as 5 DCLF commands are allowed in a CL program. In that case, each DCLF command must specify an open file identifier, a name to uniquely identify each declared file. If the program declares only one file, the open file identifier is optional. For example, this is how you will declare a file with an open file identifier, that you will write the name of the file, and then you will use a keyword open identifier, and then you will give this file an open identifier. Turning to page number 104. This command makes the employee master file available to the CL program with an open file identifier of EMP master. The open file identifier need not match the file name, but most programmers prefer to make them the same. The open identifier that you have, it must follow the rules for the simple name. When you declare a file with an open file identifier, CL prefixes the names of the CL variables from that file with an open identifier and an underscore. So in this case, the fields EMP NBR, the variables will now be ampersand EMP master underscore EMP NBR. So all the variable names will be preceded by the open ID. So it's underscore, open file identifier, underscore, and then the field name. A variable name that is prefixed in this manner is called a qualified name. Be careful to make the distinction between processing a file in your program and using your program to perform an action using a file object. For example, you can use the copy file command to copy a file without declaring the file in your program. If, however, your CL program performs read operation from the file, you must then declare the file. Page 104, DCLF examples. Go over these examples at the bottom of page 104. After that, look at the chapter summary and the keywords. And when you're done, give me a green check when you're done with going over the DCLF examples. chapter summary and the key terms. So give me a green check whenever you guys are done. As I told you guys before we went on break that we will be doing some hands-on after you guys come back from the break. So take this opportunity to log into the V2 Cloud and open RDI. And let me clear your screens. Sorry, clear your feedbacks so that you can give me new feedback when everybody is able to open RDI and is also able to log into a green screen with an RDI. Okay.
And then I'm sorry, Professor Saad, did you want us to clear out the entire program or did you want us to like make a new one?
No, don't do anything. Just log into RDI, just open RDI, log into the green screen from within RDI, and also be able to log into the regular RDI environment. So that's all I want you to do for now. Don't create anything.
Thank you, thank you. I totally forgot about the logging into green screen.
Looking at Aiden's comments. uh,
How do we get there again? One drive or one login?
get where?
So the V2.
Oh, it's your one login. In the one login, then you can click on V2 Cloud. Yeah, in the wintertime, when you have those warm clothes coming out of the dryer, oh my God, you really, really want those around you. Yeah,
Could you show how to open the green screen one more time, please?
okay. So what you do is you right click on the deathstar.gtc.edu and then you choose host connection emulator. And I'll open up this tab and then you'll log into that.
Oh, thank you.
Mhm. So these are a couple of examples that we did with our hands-on piece. We have a hello world example that we did. And then our program number 2 was about declaring a variable to grab the time. So we declared a variable, something that we learned today, how to declare variable. We actually practiced that last week. So declaring a variable with keywords and declaring a variable with positional. So we declared 2 of them. And the time variable that we declared on line 107 of type character length 6, we use that to retrieve the system value of the time and push it into that variable. And then on line 117, we displayed that the current time is, and we concatenated that with the time variable. And that was basically our program. So as soon as the remaining people, which are like 4 or 5 of you, give me a green check that you are all set, then we will start with our first program for today. Still have Christian and Victor left to give me an okay. Okay, so I'm creating a brand new member. We're going to name it exactly the same way that we have been naming previous ones, which is SP22 Prague 03. And then CLLE will be the type. And then you hit finish.
And that was CLEE.
Yeah.
Thank you so much.
Mhm. Who remembers where I got this from?
From Blackboard.
Yep. So Blackboard course description, I copied that and I pasted right here.
I'm sorry, where is this in Blackboard?
Under this week, you will find it under
Oh,
a
okay.
heading that says program description.
Even when I paste it, it doesn't show up.
Oh, there is a way to do it. You copy it. Try right click. Does it gives you a paste option when you right click?
Yeah.
Okay, click on that. Does that brings it?
Nope.
Okay, now go back to the Blackboard and right click copy. Don't use the keyboard shortcut. And then right click paste here.
Still nothing.
Really, that worked for me because that was initially doing the same thing for me. So that's what I did. I selected or right clicked and copy. Then I came here and then I right clicked and paste. That's what I did. Worked
Might
for
have
me.
to allow clipboard access for the V2 website.
Say it again.
He might have to allow clipboard access to V2.
I didn't do anything extra.
Yeah, some browsers I know sometimes they'll block clipboard access and stuff.
Oh, okay.
No.
Oh, so this basically the copy paste button at the bottom. This is your clipboard. That you can try that if it was brought into your clipboard. And then you can copy paste from there.
All right, it works.
Okay.
You said in Blackboard under course home?
No, under this week.
Oh, okay.
There is a link, there is a heading called program description. You click on it and that's where you'll find it.
Okay. Got it. Thank you.
So what is the first thing that you do in a program? Out of the 4 parts? The required piece, the first one? After the comment? Comments are optional. So the second part is what? Chapter 6?
Linkage.
Yep, linking, very good, very good. So I'm also referring to the pages as we're going over. So page number 83, we did the program information section. Now we're doing the program linkage section. So we type here the PGM in the program linkage section. Let me turn on my caps lock.
I'm having a brain for how do we delete a line again?
Oh, D, you type here in the column D, and then you type a number and then press enter. Those many number of lines will be deleted.
Oh, okay, so I was right. I just didn't want to do it and mess something up. Okay, thank you.
Mhm. And you have an end PGM for ending a program. Okay. Do you have to have a declaration section, or can you write a program without a declaration section?
I don't think you need it because it'll automatically do it if you don't.
Yeah, like for example, the very first program we did 2 weeks ago, the Hello World program, notice we never had the declaration section. So it's quite possible for you to have it without a declaration section, okay? Then it's always a good idea to have labels, like I can have a start label here, and I can put my end label here. Not that it's required, it's just a good practice of labeling that helps you in the reading of your code. So let me delete one extra line from here, okay, just like that. Okay. Now, what command is used to display the library list? What CL command is used to display the library list?
ESPLIBL.
Yeah, display the library list. Okay, so you can run a command directly from CL, and we'll just see how the command runs from CL and how does the program behaves. So we'll have send
Yeah.
program message. The DSPLIBL command ran successfully. Okay. Make sure you save the changes.
I know we probably just read this. I think I just did at least. How am I getting these white spaces to align in the RPG, or I'm sorry, RDI? So I want my backspace, like my ending comments, so my star slash, I want that to be all aligned in one line like yours is, but mine is different.
Or just, yeah, for example, when you were typing, it went like this. So just hit the delete key and delete extra spaces.
It's weird. Mine doesn't do that. Mine only deletes them and moves across when I tap.
Oh, because your insert key is on, maybe. So do you have a blinking cursor or do you have a block cursor? Do you have a block cursor like this or do you have a blinking cursor?
I had a block. Now I have
Yeah.
a cursor and I can do that.
Yeah.
So that works. Thank you.
Mhm.
How do I switch it from block to the other one?
Just press the insert key on the keyboard.
Oh,
So insert key when it's on, it overrides. If it is off, it lets you type by appending text or editing to existing text versus overriding it.
yeah, it's not working for me.
Your insert key is not working. Like when you pressed your insert key on the keyboard, it's not changing your cursor.
No.
I can't really help with that.
Okay. I mean, it's just
It's like your
convenience,
keyboard
right?
is not getting mapped. I don't know.
Okay.
Okay, sure. So after this, you right click on the file here on the left hand side in the Explorer, or you could just click and compile. Either way, it's fine. You know, however you want to do it, it's the same option. You create bound CL. And it should come out with no errors. And there's only one warning that no variables are declared in this program. That's fine.
Hi, speaker. Sorry. Talking to my cat. She's walking across my keyboard.
Ah. Because it's looking for a mouse.
It's constantly looking for my mouse. That's the game. It looks for my cursor like repetitively and it attacks my monitor.
Wow. Okay. So now click the green screen. And after we are done compiling, we would like to call the program, right? So call SP22PROG03. So when you run this program, what it does right away, it is supposed to run the display library list command. All of a sudden, you will see that a different screen shows up. When you press F3 on that screen, they'll take you back to the console where you are right now in the main menu. And then you will be able to see line 116 getting displayed right at the bottom. So when you run it the first time, see that it takes you to the display library list. And then as soon as you hit the F3, then you can get to see the output right at the bottom that the command ran successfully.
Is it right if I see the code again?
Okay.
Hey, Professor, could you show the code one more time? You kind of went a bit fast.
It is. It's not showing for you yet?
I think you have to press F12, correct?
For what?
To go back to the main screen because it wouldn't let me press F3.
F3 should work fine. If RDI is misbehaving for you, try the regular green screen. Open it through the ACS.
It displayed properly for me.
Okay. Everybody's done with this? Okay. In the green screen, now type WRK SPLF work spool file and hit enter. You will see that the very last program that you ran can be seen in the list. You can delete everything by pressing 4. Next to, if you have a longer list, you may have to press 4 and then hit enter and then delete. So your spool file is all cleared out. It's always a good practice. So keep clearing your spool files so that you don't have unnecessary stuff in your spool file taking up the resources and the space. Now, after you're done with that, come back to your program 03.
So I tried calling the program. It wasn't working for me.
It was not like, what do you mean it was not working for you? Like, did it?
The first program, SP22 Prog 3.
Right, that's what I'm saying. What is it that was not working? Like, it was not displaying the list, or was it not displaying the output, or was it not doing anything?
It says program SP22 Prog 3 in library, LIBL not found.
Yeah, because you probably didn't compile it. Did you compile it?
I did. At least I thought I can do it again. Compile CRTBNDCL.
Right, so you have to bound CL, right? Exactly.
Okay. We can go back and then call it again. Yeah, I'm getting the same error.
Okay, how about you share your screen? Let's see what's going on.
Wait. Nope. It worked. I didn't put a 0.
Oh, okay, okay.
Thanks.
Okay, so now save your program as the current program, which is 03 as 04. So SP22 Prog 04. And make sure that in the list, it refreshes on the left-hand side in the Explorer, and you can see 03 and 04. Then we will make modifications to 04. So make sure that you are editing 04, not 03.
Wait, I'm sorry, mine did not work. Repeat just exactly like the step process really quick. So I go on to step prog 3,
What do you mean? Oh, you're
like to
pre-
copy it to copy to prog 4. Do I just create a new member?
No. You did your Prog 3 worked, right?
Yeah, it worked
compiled-
perfect. Yeah, it worked perfect.
So you basically are in Prog 3 and you click File, Save As. And then you replace the number 3 with the number 4 and hit OK. Okay?
Yeah, I think so.
Okay, cool.
Yeah, it worked. Perfect.
Now, let's make changes to the number 4. So what I want to do is, I want to spool library list to output Q. So for that, I will display the library list and I will send it to the output queue, just like that. Once you're done with that change, go ahead and compile it. It should come back with no errors, just the same warning that there are no variables found. Is everybody with me so far? I'll show you how to call this one a little different. It'll still be called the same way, but let me show you how these commands will work. So I'm going to call it now. I can just go here, press F9, and I can say call SP22 prog 04 and hit enter. What it does, it first does exactly the same thing as before. So you're like, oh, okay, didn't make any difference because line number 115 ran. When I press F3, it comes back and tell me that the display library command ran successfully. Now you may be like, okay, where in the world line 117 go then? Well, line 117 went in the work spool file. In the spool file. So you have to access it through the work spool file. So you will now type WRKSPLF on the command line, WRKSPLF, work spool file. You will see two entries here now. The first entry is the program compilation. The second entry is your output print. Remember we said here that I want my display library to send to the print output queue, and that's what this is, the second entry. So you go to the second entry, which is QPRTLIBL, and you choose option number 5 to display its contents, and you press enter, and now you can see exact same output that you were seeing on screen in the staging queue. Okay. You F3
For
out
some
of here.
reason, I got something a lot different. Did you write something extra in prog 4 after the send message for display library? Because I sent it to the spool library.
No, I didn't write anything different.
It's really weird because mine gave me a different. Let me check what it's called. So work spool. It gave me a QP job log.
Okay, go ahead and check that. Choose option 5 there. What is the output of that?
1 second. Display spooled file.
You know what? Show me your share with me your screen because I can't really tell much from words.
All right.
Okay, F12 out of here. Okay, go to the command log at the bottom. Okay, click the command log. Okay. press F9 twice. Again, okay. Oh, run 04. Did you run 04? Enter. Okay, now F3. F3. It's not
I'm
working.
pressing it. This is what I mean.
Oh, press F12.
Yeah, I did.
Okay. Now press F5.
On the cube, on the.
No. Just press F5, the function key F5. Okay.
Okay.
Do you see QPRT? Because I think you never ran your number 4.
Oh, okay, okay, that makes sense. And then so
Yeah.
I display this with 5.
Yeah, here you go.
Cool.
So every time you compile, you have to run the program to see its output. And Oscar, you might have done the same thing. Now let's delete all the entries. So spool file is empty again. And let's go back to prog 04. We will now save prog 04 as prog 05. So change the 4 to a 5. Oh, Aiden is it's not letting you run your program. What do you mean? I need more description than that. Specified directory not found. Share your screen. Otherwise, I can't really tell what's going on. Oh, click OK. Okay, go ahead and compile this. Okay, now go to the green screen and run. Oh, go to the green screen. Yeah. And F3. Okay. Press F5, function key F5. Okay. Now hit 4 on all of them. Delete everything. 4, 4, 4, 4. No. Go to work spool file. And put 4 next to all the items and hit enter. And hit enter again. Okay. Now at the bottom, type call space sp prog 04. Enter. Okay. Oh, it's sorry, SP22. My bad. SP22 prog. SP22. No. There's an extra P there. It is SP22 prog 04. Enter. Okay. Now press F3. Okay. Now press F5. Function key F5. Okay. Do you see that QPRT-LIBL? Choose option 5 next to it under OPT. Put number 5 and hit enter. And here you go. So you guys have to remember to compile and then call. So some of you are compiling but not calling. Some of you are calling without compiling. So you have to make sure that you do both. Okay. So now save your prog 04 as prog 05. I'm going to make some changes to prog 05. I will not be using display library list command anymore. I'm using display job log. That's a different command. And I'm going to do display job log. That's the command I'm using instead of display library. And I'm still sending it to the print output. So display job log command ran successfully. Okay. So just made those 3 changes. Okay, everybody got this? Now you are supposed to do what first? Compile. Once you're done compiling and it comes back without yelling, then you go to the green screen and the first thing is you call. It takes me to the displayed job log. That's a job log for this particular program. I made a call, okay? I come out of it, F3. And then if I'm already sitting in work spool file, I'll hit F5 to refresh it. If I'm not in the work spool file, then you can type work spool file and get into the work spool file. And you will now see the QP job log, which is not QP print. It was a different one before. I'll go to the job log by choosing option 5 on it. And here I can see my job log for this particular job. And I can see all the details of the job log. It had 2 pages, okay? So that pretty much shows the entire set of processes I did, the work spool file, the calling of the program, and all the display. I mean, all the jobs connected here are shown right here, okay? Okay, so now, is everybody done with this one?
I'm not yet. I still have to call it.
Okay.
Okay, so it's in display job log right now. Is that where it's supposed to be?
No, you press F3, you come back to the previous screen, and then are you in work spool file or are you outside of the work spool file?
I'm outside.
Okay, then type work spool file and get inside the work spool file.
Okay.
And then you should see one of the entries as QPJ job log, and you choose option 5 next to it to see the job log. And then when you come out of the job log, then use option 4 to delete all the items in the spool file. So that is emptied out.
Okay, where do I see the message that we wrote? The audio's cut out. I can't hear you for some reason.
Oh, the message doesn't shows in the work spool file. It shows in the menu. So
Okay.
yeah, if I were to run this program from here, it shows the job log. I come out of it. I see the message. Then I go to work spool file, and then I can look into my job log. Okay.
Okay. So then it's kind of just, you're allowing yourself to see whether or not it ran successfully.
Yeah, so if I'm in the work spool file, then the work spool file doesn't have this extra area to display the outputs. That's
Okay.
only in the menus.
Got it.
So now we will save 05 as 06. And let me change this back to a different command, display library, as opposed to display library list. And I want to use a keyword library to display one particular library called QGPL. And I'll make some changes to line 117 as well, that I want to see the display library. I want to see specifically the library called QGPL and send that to the staging area in the output. So make these changes. And then you know the drill. After you make the changes, you save, you compile, you call, and you check the work spool file. You save, compile, call, and then you check the work spool file. Those are the first steps that you got to do. And let's see if you can do this yourself this time versus me having to lead you through the process.
Do you want us to view it in the spool file as well?
Did you read my comment? Line 123? Save it, compile it, call it, and check the work spool file. So you can see that whatever command you're running, it puts it in that QP followed by the name of the command. That's the staging area for that. Victor, you right click on Death Star, you go to host connection emulator. Right click on Death Star and click on host connection emulator. Okay. So now we will save the program 6 as program, rather, let's not save program 6. Let's go to program number 2. Open program number 2 and save that as program number 7. Let me double click to open program 2 again. I think it didn't save number 7 for me. So I double click on program number 2 again. And now I'm saving it as program number 7, because sometimes what happens, our RDI doesn't register properly the names until you open it again. If you're looking at the old snapshot, it's not even in the memory. So that's always double click to open and then save as. So that's why I double click to open program 02 and then save it as program 07. So this was the 02 program that we created last week. So I'll change the date from 2nd to 8th. So make sure that you can see number 7 in the list in the Explorer as well. That's important. Otherwise, you'll do all this work and nothing will be registered behind the scene. Now, let's delete line number 108. I don't need that line anymore.
What do we have to do to make sure all the work is saved?
Just make sure that you can see under your source physical file 07 as one of the items listed.
Okay. Yep.
Yeah. So I am deleting line 108 by typing D1 in that line, and pressing enter will delete that line. I'm changing the name of my variable from time to date time, where I'm changing the length from 6 to 20. Instead of retrieving only the time, I will retrieve the date time and I will put it in the variable date time. And now I'm displaying the current date and time is date time. So make the necessary changes. After you are done making the changes, make sure you save, compile. How do you get it to appear in the file? What do you mean? I mean, when you save it as, it automatically should show here. Is it not showing for you when you save number 2 as number 7, Aiden? Yeah, that's what I asked, that you should double click on number 2 first. Make sure number 2 loads here. Then click File, Save As, and save it as number 7. Because what it does, if the tab was already opened, you are looking at a tab that doesn't really exist behind the scene. So open a fresh tab of 02 and save it as 07. and then make the necessary changes. And before you make the changes, make sure that 07 shows up in the list now. So do not work with already opened tabs when you're saving as. Always reopen those, because RDI sometimes shows you a tab, but doesn't really takes a snapshot of it. So again, whenever you're done making the changes, save it, compile it, and then call it. There is no spool file involved in this one. So you don't need to check the spool files because I'm not sending anything to any, staging areas. So all you need to do is just simply, I have to be back in the main menu.
I'm having an error when I try to run it.
Okay, let's see. It works fine for me, so there can't be a syntax error. Maybe you might have made a mistake on your end somewhere. So check the code.
It says that the job in system queue is allocated to another job.
When you try to run it,
Yeah.
well, let's have a look at share your screen. Yeah, I mean, over here, just type I and hit enter. Okay. Now, can you show me your source code? Okay. Clear. Oh, because see, your length is still 6. Change that to 20 on line number 106. 6 cannot hold that long value. That's why. No, change that to 20, 20. Okay, save the changes, recompile. And then, hit F3, yeah, and F9. Press F9 and hit enter. Hit I again. Okay. Type work spool file. Enter. Okay, delete all of these. Enter. Okay, F3. Go back to your source code. Maybe I missed something else. Retrieve system value, Q date time. In the date time. And then your send program message. The current date time is ampersand date time. Compile it again. You have to click somewhere in the editor, and yeah, and now. Okay. Hold on. Just double click on the tab. Just double click on the tab. Right. Okay. Yeah. Now compile. Okay. Can I check your error? Can you show me your error list? See, you have errors. Variable date time is referred to but not declared. Can you close this 07 tab? Just exit out. Yeah. And double click on 07 from the list on the left. Okay, now let's also, do you see that keyword in a slightly different color?
Mhm.
Yeah, can you go before that slash and hit a space? Turn, yeah, okay. Turn, yeah, okay. Okay, now go to the new line. I mean, like, go to the next line. Let's see if the color changes to green. Yeah, okay. That might have been another issue. Try to save the changes and recompile. Okay, now because the program had errors, that's why it was failing when you were trying to call it.
Okay.
So go to the green screen and F9. Again, you know, yeah, hit enter. Yeah, here we go.
Okay.
So basically, when we look at the output here, it shows us 2022-0209. It is 4, 16 is 4, followed by whatever time I ran it. I ran it at 4:53, so it's 4:53. And then it's 46 seconds, and then followed by the rest of the microseconds. That's a timestamp, the entire timestamp. Everybody get to see that? Okay. Now go to the blackboard and look at, for those of you who did not do the quiz, you have a quiz to work on. And then there's an assignment, assignment number 4. I'm asking you to complete some review questions from chapters 6 and 7. And then when we are back in class next week, we will be looking at chapter number 8, which is about variables as well. It's about working with variables. And then we will be doing a lot of examples because it introduces some functions. Again, it's a 14-page long chapter. It'll be introducing some functions. So we will then be able to do some more examples, introducing what we learned in chapter 6 and 7 and then 8. And we'll be able to do some more examples like that. So that's all for today. Make sure you guys are familiar with green screen during the week. Looks like your green screen stuff is a little bit rusty. So that's why I made available the tutorials for you. I mean, like the examples that we did in class are also in the YouTube tutorials right here. There are a couple of the tutorials. It just goes over the examples that we just did in the class. And review these things before you come to class so that you know you are a little bit more familiar with this environment, so that we don't have to spend so much time trying to relearn the environment. You know, I see so much love for this environment from all of you. It just is a disservice for not doing it, right?